Hello class, welcome to Unit 9, Lesson 5. Today we're going to continue looking at complex zeros. So we are going to factor polynomials completely and find its real and complex zeros. We're also going to state the multiplicity of the zeros and then figure out how to write the polynomial equation given its real and complex zeros. So the first thing we're going to do is just remind ourselves, how does the degree affect the number of zeros? Okay, if your degree is 1, you should have 1 0. Okay. If your degree is 2, you should have 2 zeros, 3 zeros, and so on. So whatever the degree is, you should have that many zeros. Also remember your number of zeros, and if you add up your multiplicity, those should equal each other. Okay, so your multiplicities, your number of zeros, and your degrees, those should all be the same number. They should add up. So if I have a degree of 1, which is a linear equation, how do you guys find zeros? Well, to find a zero, you take your equation and set it equal to 0. If I set this equal to 0 and I add 4 to the other side, I will have x equals 4, multiplicity of 1. Okay. The next one is a quadratic. If I set it equal to 0, the way we solve quadratics is by factoring. So it multiplies to 25 but adds to negative 10. So x minus 5, x minus 5. So in this case, when I solve it, I would get x minus 5 equals 0, so x will equal 5. Not once, but twice. So x equals 5, and since it happens twice, I'll have a multiplicity of 2. Okay. The next one, it's a cubic. I would first go ahead and GCF. My GCF would be x, and then I have x squared plus 1. Then I would set each part equal to 0. I would have x equals 0, so that's 1, 0. Multiplicity of 1, x equals 0, multiplicity of 1. And then I'll have x squared plus 1 equals 0. So x squared equals negative 1. Take the square root, and we get plus or minus the square root of negative 1. The square root of negative 1 is I, so it'll be plus or minus I. So x will equal I, multiplicity of 1, and x will equal negative I, multiplicity of 1. So once again, I add up my multiplicities, I should get my number of zeros. I should also get the degree of my polynomial. Okay. Then I would go ahead and look at example or problem 4 with a degree of 4. I would set it equal to 0. And then I would try and factor it. Since there's an x to the 4th in the front, I would go x squared and x squared. Then what multiplies to 81 but adds to 18? We'd have 9 and 9. Okay. I would solve this. I would take my x squared plus 9 and set it equal to 0. Subtract 9 to the other side. I get negative 9. And then I have x equals plus or minus the square root of negative 9. The square root of 9 is 3. So I'll have plus or minus 3. And then we have the square root of that negative makes it 3i. If I were to do this with this other set of parentheses, I'll get the same answer. Plus or minus 3i. So that tells me I have one answer, x equals 3i, and the multiplicity is 2, and x equals negative 3i, multiplicity of 2. Okay, and then the last one, 5th degree polynomial, setting it equal to 0, and I would factor it. Look for GCF. This one has a GCF of x to the 3rd. Then I would have x squared minus 2x plus 1. I'd have x to the 3rd, and then I would try and factor this using multiplying to 1 but adds to negative 2, so x minus 1 multiplies to 1, adds to negative 2, so that's good. When I solve this piece, I'll get x equals 0, and it has a multiplicity of 3 because it's to the 3rd degree. And then x minus 1, when I solve that, I'll get x equals 1, and it has a multiplicity of 2 since it will happen twice. And I would check 3 plus 2 is 5, so that matches my number of zeros. It also matches the degree of my polynomial. Okay. So this is what we're going to be doing today. Some answers will be real zeros, some will be imaginary or complex. So let's go ahead and just look at example 1. Okay, example 1, we need to go ahead, factor it completely, and then find all of its zeros and state the multiplicity of each zero. So first things first, look for GCF. There is a GCF of 3x. Then I would have x to the 4th plus 8x squared plus 16. Then I would try and factor this part down further. We would have x squared and x squared, what multiplies to 16 but adds to 8. 4 and 4. These I cannot factor down using difference of squares. So what I would do is set them equal to 0. So my zeros, I'm just going to write out over here. when I set this equal, I will have x squared plus 4 equals 0. Then I have x squared equals negative 4. When I take the square root, I'll have plus or minus the square root of negative 4, which gives me plus or minus square root of 4 is 2, square root of negative 1 is I. If I were to do that here, I would also get the same answers. Okay, so to be factored all the way, my completely factored answer would be 3x. Then in parentheses, do you guys see how I have two positive 2 square root of i's? I would have x minus 2i squared, because it's going to be a double. And then I would have x plus 2i squared. Because before when we had answers like x equals 2, what did I have in parentheses? X minus 2. When you had an answer of negative 2, what did you have in parentheses? X plus 2. It's always minus. So x minus my positive 2i answers. There it is in factored form. And then x minus a negative 2i gives me plus 2i. So here is my factored form. Now I just need to list the multiplicity, or my zeros and their multiplicity. So my zeros, x equals, I set this equal to 0, I get 0, multiplicity of 1, to the first degree. Then I'll have x equals 2i, multiplicity of 2, and x equals negative 2i, multiplicity of 2. So 2 plus 2 plus 1 gives me my degree of 5. So it's a good way to check to make sure you've gotten all your zeros. All right, example 2, we are going to skip. We are going to come back, though, at the next problem. We'll do sum and difference of cubes. So something that you guys have used in pre-calc 1. So that'll be coming at you again. We're also going to skip example 3, but let's look at this one. This one is good. It uses the ideas from example 2 and 3 all in one problem. Okay, so we're going to use sum and difference of cubes at some point, and we're also going to use a difference of squares. So I notice right away 64 is a perfect square, and I can take the square root of x to the 6th. So let's do this. If I take the square root of both of these, the square root of x to the 6th, anything to the square root is really to the 1/2 power, and then when you have power to a power, you multiply. So 6 times 1/2 is x to the 3rd. Okay. So when I factor it, I would have x to the 3rd in the front. And then my square root of 64 is 8, so 8. And then remember, we always have a plus and a minus. Now, I have difference of perfect cubes. I see that these are to the 3rd power. So I'm going to use these formulas from pre-calc 1. Okay, so I have a positive and a negative, so I'm going to use both equations. So we're going to ignore these signs because these equations already have taken them into account. Okay, so let's figure out what is a and what is b. A cubed is equal to x cubed. So if I take the cube root on both sides, I will know that a is equal to x. Okay, so a equals x. And then b cubed is equal to 8. And if I take the cube root of 8, I get b is equal to 2. So using that idea, I'm going to go ahead and factor. This piece, I will be writing into this equation. So a plus b, so I will have x plus 2. Then I have my a squared, so x squared, minus 2 times a. So, sorry, a times b, which is x times 2, so 2x, minus 2x. Then plus my b squared, so 2 squared is 4. Then I move on. The next one, I'll do it in a different color. The result of x cubed minus 8 all the way factored will be here. We will do x minus 2, a minus b. Then your a squared, so x squared, plus your a times your b. So I will have 2x, and then plus your b squared, which is 4. Now I would have to continue to factor. This is something to the 2nd degree. So the way I would factor that is I would try and make 2 sets of parentheses and say what multiplies to 4 but adds to negative 2. That's not possible. So in order to factor this down, we have to do the quadratic formula. Okay, so quadratic formula, I'm actually going to take it to the other side, or a new page, sorry, plus. So I have x squared minus 2x plus 4. To find my zeros, I do quadratic. So x equals opposite of b, which is currently negative 2, so positive 2, plus or minus the square root of b squared, minus 4 times a, which is 1, times my c, which is 4, all over 2 times 1. there we go. That's clear. So negative 2 squared is 4. 4 minus 16 will give me negative 12. So this is 2 plus or minus the square root of negative 12 all over 2. This can be reduced. Okay, it's really 2 plus or minus the square root of negative 1 times 4 times 3 all over 2. Square root of negative 1 is I. Square root of 4 is 2, and then the square root of 3 is not a perfect square. So then I notice all of these are divisible by 2. So we have 1 plus or minus I square root of 3. Those are two zeros. 1 plus I square root of 3, and the other one is 1 minus I square root of 3. Then I need to do the same process, but with this factor, because there is nothing that multiplies to 4 but adds to a positive 2. Okay, so I'm going to write that down. I will have x squared plus 2x plus 4. I will quadratic formula again. Okay, but one thing is, be aware, what is really different here? Okay, my b is different, and that's it. So x equals opposite of b, so it's going to be negative 2 plus or minus the square root. Positive 2, sorry. Positive 2 squared minus 4 times 1 times 4 all over 2a. So what's really going to change? This front number will be negative, and then if I take a negative and square it, it becomes positive 4. If I take a 2 and I square it, it's positive 4, but everything else is the same. So I know that this is going to be the square root of negative 12, and I know what that reduces to. Okay, so I can jump to the conclusion, based off my other work, that this is going to be a negative 2 plus or minus 2I square root of 3 all over 2. And once again, I can divide them all of it by 2. So I'd have negative 1 plus or minus I square root of 3. Okay, so here are my zeros. Okay, and I need to use those. So I'm going to go back, make a little note. My zeros. X equals, was it 1 plus? Yes. 1 plus or minus I square root of 3. Also, x equals negative 1 plus or minus I square root of 3. So now in order to write this all the way in factored form, it's going to get crowded, so write small. P of x equals x plus 2. Now, what did I have in parentheses before I got this? You would write x minus, and then all of one of your 0. 1 plus I square root of 3. Another set of parentheses, so there's one factor. Then you do the other one. Instead of writing the positive, you write the negative. So it's going to be x minus 1 minus I square root of 3. Okay, there is all of this piece factored with my zeros. So this should be one long line of factors. So we're going to continue. Now we'll have x minus 2. Then I will have x minus negative 1 plus I square root of 3. Notice how there's two parts to these zeros, so you have to put them in parentheses. And then lastly, x minus negative 1 minus I square root of 3. You don't have to simplify these any further, but make sure they have them in parentheses. So here is my polynomial factored all of the way. And now I need to list my zeros with their multiplicity. Okay, I kind of listed them here, but let's go ahead and write them out each individually. So x equals 1 plus I square root of 3. That has a multiplicity of 1. Then I would write x equals 1 minus I square root of 3. Multiplicity of 1. X equals, then I'm moving on to this one, negative 1 plus I square root of 3 with a multiplicity of 1. X equals negative 1. Negative 1 minus I square root of 3, multiplicity of 1. And then finally, don't forget about the easy ones. X equals negative 2, multiplicity of 1, and x equals 2, multiplicity of 1. So I would count out my multiplicities 1, 2, 3, 4, 5, 6. It was a 6th-degree polynomial. So there it is. There are all my zeros. My zeros are listed here, and here it is in factored form for example 4. All right, example 5. We are going to do the opposite. I gave you the zeros, and now you need to go ahead and go back to what the polynomial looks like originally. Okay, so it tells me it's a 4th-degree polynomial, and it's giving me 4 zeros, so that's good. I always make sure my degrees and my zeros match up. And then it tells me P of 3 equals 25. Okay, so we'll have to take that into account in a little bit. So let's just first of all start with our zeros. So we really have P of x equals, in parentheses I would have x minus I. Then I'll have x minus a negative I, so plus I. Then I have x minus 2 and x plus 2. I would FOIL these two together. I will have x squared plus ix minus ix. So those will cancel. So there's none of those. So if you wanted to write it out, you can. Otherwise, it's minus and then I times I squared. This one right here, same thing. We'd have x squared, then plus 2x minus 2x. Those cancel, and then lastly, we'd subtract 4. This gives me x squared minus I squared is negative 1. This is really x squared plus 1 and x squared minus 4. Now we're just going to go ahead and FOIL, distribute until we get it all the way into our polynomial. So we would have x to the 4th minus 4x squared plus x squared minus 4. Then I will have x to the 4th, combining like terms, minus 3x squared minus 4. There is my polynomial with my zeros, but now it's telling me when I plug in 3, I should get out 25. So let's check what happens when I do this. P of 3. I'll have 3 to the 4th minus 3 times 3 squared minus 4. What do I get out when I plug it in? So if you type this into your calculator, you will get out an answer of 50. Is that what I want? No, it is not. So how do I go from 50 to 25? Well, I take and I would divide everybody by 2. So to get my polynomial that satisfies P of 3 equals 25, I take my polynomial and divide everybody by 2. The same as dividing by 2 is multiplying by 1/2. So I'm taking this guy, yep, and multiplying by 1/2. So my final polynomial, 1/2 x to the 4th minus 3 over 2 x squared, and then minus 4 times 2, so minus 2. If you plug in 3, you should be able to confirm you get out 25 this time. Okay. There is example 5. Then we got the conjugate zeros theorem. Okay, if the polynomial p has real coefficients and if the complex number z is a 0 of p, then its complex conjugate is also a 0 of p. So what it's saying is if you have a plus bi and it only tells you a plus bi, then you also know a minus bi is a 0. If I tell you x equals negative 3i is a 0, you also know the opposite of it is a 0, 3i, positive 3i. Those are conjugates when they do opposite sign in the middle. So if 3 minus I is a 0, then blank is also 0. So it's the conjugate of this. This is a negative in between, so change it to a positive, and there's your other 0. Okay. So here's where that comes into play. It tells me in example 6 that we have a degree 4. My zeros are negative 2 and I, where negative 2 has a multiplicity of 2. So if I have a multiplicity of 2, and then I have this one, I'm only at a degree of 3. But by my conjugate theorem, I know that if x equals positive I, it also equals negative I, okay, with the imaginary pieces. That is always true. So we want to find the polynomial with integers, so this means whole numbers, no fractions, that satisfy the condition. So my polynomial, setting it up, I will have 0 is negative 2, and it has a multiplicity of 2, so x minus a negative 2, so x plus 2 squared. And then I would have x minus I, and then x minus a negative I, so x plus I. Then I would write this twice and FOIL it. And if I FOIL this part, I will have x squared, then I will have positive ix and then negative ix. So those cancel, and then negative I times I, so a negative I squared. This will give me x squared plus 2x, so plus 4x, plus 4. And then it'll say x squared minus I squared is negative 1, so plus 1. Then I just have to continue FOILing, distributing, all that. So we will have x to the 4th plus x squared. Then I distribute this plus 4x cubed plus 4x. Then plus 4x squared plus 4. Then we just go ahead and combine our like terms. Oh, got a little carried away there. Those are not like terms. plus 4x to the third, and then I'd have this one, so plus 5x squared plus 4x plus 4. And then I just confirm, it says integer coefficients, positive and negative whole numbers. Yes, there's no fractions. So there is my polynomial that would satisfy this, and I would just confirm, is it a degree of 4? Yes, it is. Okay. Example 7, last one. Find a polynomial with integer coefficients that satisfies the given condition. So it tells me degree 3, and my zeros are 2 and 4 plus I. Well, if 4 plus I is a 0, so is the conjugate, 4 minus I. So I have 1, 2, 3 zeros. So let's set it up. P of x will equal x minus 2. Then here's where you gotta be careful. This is a binomial, so it's gonna be x minus parentheses 4 minus I. Okay, putting it all in parentheses. And then you'd have x minus, and then it would be 4 plus I. So this gives me x minus 2. When I distribute this, I will have x minus 4 plus I, and then I will have x minus 4 minus I. I am going to ignore my x minus 2 until the end, and I am going to distribute and multiply all that out. I'm going to go way over here, though. So we got x minus 2. We will have x squared minus 4x minus ix. That's by distributing my x. Now I'm going to distribute a negative 4. So I have minus 4x plus 16 plus 4I. And then the last one, I. So we have plus ix. Wanted that to be a different color, sorry. There it is. Plus ix, then minus 4I, and then minus I squared. There is these two sets of parentheses multiplied out. So let's simplify, see what we got. We will have x minus 2 in the front. Then we have x squared, and this will cancel. So it's good. Then I will have this and this will cancel. So that is nice. Then I'll have x squared. Let's see. We got negative 4x and minus 4x. So I got negative 8x. Then I'll have plus 16. And then I have minus an I squared. So minus negative 1. So it's really plus 1. So it's going to give us 17. So we have x minus 2. Then I have x squared minus 8x. And then minus a negative. So plus 17. Then we distribute. We'll have x cubed minus 8x squared plus 17x. Then we distribute our negative 2, so minus 2x squared plus 16x. And then negative 2 times 17, negative 34. Okay, then I continue, is that everybody? Yes. Then I combine my like terms. So P of x will equal x to the third minus 10x squared, 17x plus 16x should give me 33x minus 34. So there is my polynomial, and I would confirm integer. No fractions or anything weird in the front. They're all whole numbers, so that's good. Positive and negative whole numbers. They are integers. That's what that makes them. So that is example 7. So your homework is page 298, or if you use the electronic PDF, page 327, 12 through 28 evens, 31 through 36 all. If you have questions, feel free to message me. Otherwise, have a great day.